Hello students, let us see this problem. This problem came in Jest 2012, and they say the ground state of a particle moving in a one-dimensional potential is given. So you have been given is psi x is equal to exponential minus x square by 2, and then you have been given a cos hyperbolic root 2x. So this wave function is given, and now they're asking what is the potential. So wave function is given, you want to potential, that means you have to use the one-dimensional Schrodinger equation. You have a h cross by 2 del 2 psi upon del x square plus Vx kinetic energy plus potential energy equal to total energy E psi. So we can find the Vx from this equation. So how can we find Vx from this equation? We can write now, say Vx psi x is equal to E psi x, and this term you can bring here this side. So this will become h cut square 2m del 2 psi upon del x square. Now I want Vx. So Vx will be simply E upon 1 upon psi x h cut square 2m del 2 psi upon del x square. So only you need to differentiate correctly. The problem is simple. You have given wave function, and now you have the formula. This one, and they say question. They say take unit mass h equal to 1. So you can further simplify this equation. You can write here Vx as say Vx will be simplified further. This will become E plus 1 upon, this is a 1, so this will be 1 upon 2, 1 upon 2, 1 upon psi x, and then you have a del 2 psi upon del x square. So we have to solve. Now we have to find double derivative of the wave function. So you have a wave function I'm writing here. So I want del psi upon del x. So this e power minus x square by 2. If I differentiate this one, this will give me minus x e power minus x square by 2 cos hyperbolic root 2x. And now if I differentiate this term, this will give me e power minus x square by 2 cos hyperbolic will give me root 2 sine hyperbolic root 2x. Now I have to differentiate double differentiation. So you have to be careful. Del psi upon del x square. Now here are three terms. Here I have two terms. Okay. So I differentiate using the product rule. So this first term I replace 1. So I will be doing 1 e power minus x square by 2 cos hyperbolic root 2x. Again, this minus x, if I differentiate this one, so I'll get again minus x. So minus x is minus will become plus, this become x square and e power minus x square by 2. And here you will be having cos hyperbolic 2 root x as it is. Again minus x e power minus x square by 2. If I have to differentiate this one, so this root 2 will come here, root 2, and then you have a sine hyperbolic root 2x. So there's three terms, and I have to do this one also. So if I do this one, this will give me root 2. If I do this one again, I'll get minus root 2 x e power minus x square by 2 and sine hyperbolic root 2x. And if I do this one sine, then root 2 will come, then it's going to 2 e power minus x square by 2. Sine will give me cos hyperbolic 2x. Now let me simplify how many 5 terms we have. So cos term is how many terms? Cos, this is 2 e power minus x square, cos hyperbolic is root 2x, and this is only minus 1. So you have one term will be remaining, this one. So one will be removed out of this, and now you have this one also. So if I take e power minus x square cos hyperbolic x common, so take e power minus x square by 2 cos hyperbolic root 2x common, and this term already disappeared. You have 1 here, so this will be 1, and here you will be having x square. So you have these two terms. Now remaining two terms you can check here. Here you have 2 root 2x e power minus x square sine hyperbolic x. Same term is here. So this become minus minus 2. 2 root 2 x e power minus x square by 2 sine hyperbolic root 2x. Now just put it in this expression. I want to find what is my Vx. So Vx will be simply e plus half. Okay. And my original function, this is psi x. This is psi x. So I'll write this is a 1 upon psi x d2 psi upon dx square will be, this is psi x 1 plus x square, and then you have minus 2 root 2 root 2 x e power minus x square by 2 sine hyperbolic root 2x. Now just you have to simplify one more step. So this is e plus half. This is psi x will be cancelled. Yes, psi x will be cancelled. So you will having 1 plus x square by 1 plus x square, and then you will be having 1 by 2. And here this 2 cancels, so you'll be having minus root 2. You'll be having x also, and if I put a psi value ex, so this term will cancel, and this will become tan hyperbolic root 2x. So this is my Vx. Now let me solve it further. This gives me e plus half plus x square by 2 minus root 2x tan hyperbolic root 2x. Now in the question it says up to an additive constant. So I will take this as a constant. So that my answer will become x square by 2 minus root 2x tan hyperbolic root 2x. So x square by 2 minus 2x hyperbolic. Hyperbolic means this one, this term B. Option B is the correct answer for this question. Thank you very much.